we are going to start new lesson, and it's about what will happen when a car takes a turn, something is moving in a curve. Lesson number 5.3, highway curves, banked and unbanked road, page number 116 of your book. We are going to talk curves. Whenever there are curves on the highway, or there is a car which is taking a turn, what will happen? If you can see the picture, when we are talking about the turn, look like this is the road part that is during the curve or during the turn. It looks like arc of the circle, so it looks like the part of the circle. If it is a part of the circle, so this part of the motion of the car is the circular motion. So if it is a circular motion, this car needs centripetal force. Now the question arises, from where centripetal force comes? The centripetal force actually comes from the friction between the tire and the road. If the tire and road have the grip, strong grip, so the car will not skid away. So it will stick with the circular path. So we can generally say that whenever a car is taking a turn, it requires centripetal force, and this necessary centripetal force is being provided by the friction between the tires and the road. If this friction is insufficient, then what will happen? As you can see in this Formula 1 race, usually cars are moving, and when they are taking a turn, they move on this black path. But if the grip or the friction between the tire and this road is not enough, so these cars rather move in this direction, they will move away on these black marks on the road. So they will move directly from here toward the direction of the velocity. And we will say that there was not enough frictional force between the tires and road. This might happen because of the tires of the wheels of the or the tires of the car are wear out, or the road is slippery, or you can say that the road is wet. For example, this is the path of the car when while it is taking a turn. This is the path of the road when car is taking a turn. And consider that this is your car. This is your car exactly. So let us consider this is the car. If we complete this track, so it seems like a circle, and the distance from the car center toward this will be the radius of the circle. Now, this motion of the car, if you consider it while it was taking a turn, only this portion is the curve, but I consider it when I complete this curve, it is a part of a circle. So now this car is a particle that is moving along the circular path. We know that whenever an object moves along the circular path, it requires a force. It requires a force. So you will say that for circular path, when you are talking about circular path, here you will say circular arc, because the curve is only a part of the circle. So for circular arc, car requires car requires centripetal force. First of all, it requires centripetal force, and you remember the value of the centripetal force is mv squared over r, and it is always toward the center of the circle. Okay, toward center of circle. So this is the direction of the centripetal force, but actually this car is heading towards this direction. So I can say that this direction is the direction of the velocity. Now, when this car was taking a turn, it requires a centripetal force. Even though you are moving the steering wheel like this, but steering wheel is not providing the centripetal force. Centripetal force is provided by the friction. This centripetal force is provided by friction. And what is the friction? Provided by friction between the tires and the road. Friction between tires and the road, Umar, now you have to listen. Between tire and road, if your tires of the car and the road has enough roughness, friction means roughness. When you use the word friction, it means we are talking about how much the surface is rough. If the more roughness of the surface, it means more friction. If more friction, more roughness, it means the grip of the car tire on the road is more. So more the grip, it means the less chance to skid the car away. If the road is slippery or wet, what will happen? The grip between the tire and the road will be less. So the car, rather to move in the circular path, it will move toward the direction of velocity tangent to the position. So if you have more friction, more roughness, you will have more grip on the road, so car will move. So generally speaking, we use this word, we use this sentence, the centripetal force is provided by this sentence. The centripetal force is provided by the friction between tires and road because of the roughness of the road and tire. If the tires are flat, if tires are weared out, or if the road is slippery because of ice, because of wetness, so the car will skid away, and you can see this be like this one. The car will move in general case toward this, but if it doesn't have uh, necessary friction, so the centripetal force will remove, the friction will remove, and the car will move away from the road. Now, as we reach at this point that we are talking about friction, so to understand this concept, we need to know the types of the friction first. There are two types of the friction that are in the circular path motion. There are two type of friction. The first type of friction that is in between the tires and the road is called static friction. What we call it?
Static friction.
We call it static friction. I will explain this. Just give me a minute. Static friction, and symbolically we use Fs for it. And the other friction is called kinetic friction. The kinetic friction is the friction that is represented by Fk. So both of these frictions are always present between the tires and road when car is taking a turn. When car is taking a turn, the centripetal force which we require is provided by the force of static friction. So centripetal force is always be provided by static friction when it is taking a turn. This static friction is always towards the center. Where it is? It is towards the
Towards the center.
center of the circular path. So it is towards the center of circular path, and if it is equal to or greater than centripetal force, then car will continue on the curved path. If it is equal to or greater than, then car will continue the curved path. If it is less than centripetal force, the car will not continue. So if you want to draw the figure for this one, you can usually say that this is the car that is taking the turn. So if there is enough friction between the tires and the road, this enough friction will be towards the center. It will provide centripetal force, and this friction will be static friction. And in this time, car will completely move in the circular path. It will not go away from the circular path. If this static friction is less than uh, the required centripetal force, then the car will skid off. So it will skid off and it will move away from this one. And if you want to see the figure, you can say that in this condition the car actually wants to move along this curved path. So this circular path, it is also directed towards centripetal force, towards the center, but Fc is greater than Fs, or you can say Fs is less than Fc. So this car, rather to move on this track along this direction, it will move toward this direction, and you will say that the car will skid. It will move toward the velocity. Now, the problem arises one, how we can calculate this static friction. I'm not talking about kinetic friction yet. I'm just talking about static friction. If you want to calculate this static friction mathematically, the formula of the static friction is Fs is equal to mu s Fn. These are two new terminologies here. Fs is used for static friction, as I told you earlier on. This is static friction. Okay. Second thing, the second terminology here is this one. And this terminology I use the word mu, M-E-W, mu. And this is mu, a Greek letter. So this is called constant of static friction or coefficient of static friction. What we call it? We call it constant
Static
of
coefficient.
static friction. What actually this thing is? This coefficient of static friction is roughness, or you can say that it depends upon nature or roughness of the surface. What does it mean? It's really difficult to understand. Let me make it simple. If road is made up of cement, the value of mu s will be, let's say, 0.6. If the road is made up of sand and you can say the soil, its value will be a little bit more than 0.6. If it is made up of glass or ice, the value of mu s will be less. It means if surface is smooth, the if surface is smooth, the mu-s will be small. If surface is rough, mu-s will be more. It has different value in different, you can say, materials, and on different condition of roughness, its value changes. So it depends upon roughness and the nature. So this is one more thing. Now, Fs is equal to mu-s, and third part is Fn. Fn is called normal force. If you remember Newton's third law, so you can remember normal force, that this is something placed on the surface. If this is something placed on the surface, so what is the direction of the weight? You know that weight is always directed toward the center.
Downwards.
So if there is only weight acting on it, it will move downward. It means there is another force that is equal to this weight and upward in direction, normal force, and this normal force equal and opposite to the weight of the object. So here in the case of the car, when car is on the road, what actually happens? If you see this figure A, there are three forces on the car. One is the friction force. This is toward the center of the circle or center of the curve, toward center. That provides the centripetal force to the car. The weight is acting downward and reaction of the weight upward. No, car is neither moving upward nor moving downward. It means these two forces are equal and opposite on the car. So Fn is equal to mg for flat road. If road is flat, it's not up and down. For flat surface, if surface is flat, you will put Fn normal force equal to mg. Otherwise we will change, but for now you have to remember this Fn is equal to mg. So this relation of static friction now changes into, we can make directly like static friction is equal to mu s, static coefficient, times mg, the weight of the car. We will use this relation to find the static friction. Before I start numerical problem, I want to go through one time. I start from here and I said when a car is going to take a turn, this car requires centripetal force, and this centripetal force mv square over r will be provided by the friction between the tires. The friction can be one of these two types. I just discussed static friction. This friction is always toward the center of the circle. So if it is more than necessary required centripetal force, so car will continue in the curved path. But if it is less than required centripetal force, car will not take the turn. How to calculate this static friction? We will use this equation mu as Fn, or you can substitute value of Fn is equal to mg. We can find this explanation you can understand after solving this numerical problem, example 5-6. I'm going to solve this, and inshallah you will understand all of the explanation which I gave to you. There is a car which is going to take a turn around the curved path. The mass of the car is given to us is 1000 kilogram. So as we guys every time aware that we need to write the given data first of all, and then we will go to solve the problem. So first thing given to us is the mass of the car. It is 1000 kilogram, and you guys know kilogram is the standard unit. We don't need to change. The radius of that circular motion or circular path is 50 meter, and the speed of the car is 54 kilometer per hour or 15 meter per second. So meter per second is our SI unit, so I will use 15 meter per second. Now the question part A and B both are the same, but what is saying, will the car follow the curve or it will skid? So actually we are going to find, is car going to take the turn or it will skid? So it will follow curve, it will follow curve or skid. This is our question that we have to solve. But for first situation, he says that when car is moving on the dry road, this is very important, car is moving on dry road and its coefficient of static friction is 0.6. So A part is, you have been given coefficient of static friction is 0.60 and the road is dry. So when the road is dry, will the car skid or follow for situation A? I told you, if the car will skid or follow, it can be understood that we have to check either Fs is greater or equal to Fc, or either Fs is less than Fc. So if it is greater than Fc, the car will take the turn. Greater than centripetal, the frictional force is more, it means car can easily take the turn. If friction is less, car will skid. So this is our point of concern, that we have to check either it will follow this statement or it will follow this statement. For that purpose, what I need to do, I need to find Fc first. And you know that what is Fc? Fc is equal to mv square over r. M is 1000 kilogram, V is 15 meter per second, and you have square it. Radius is 50 meter. Yes, 4500 Newton. Thank you so much. So now this is the required centripetal force for this car to take the turn to follow the curve. If friction will be less, car will not follow the curve and skid away. If friction will be more or equal, then car will take. So for part A, let us find, for part A, let us find force of friction. So formula of the force of friction, you guys remember what was that? The force of friction was mu s Fn, but for the time being we remember that Fn we change for, because they said in the question that it is a flat surface. So for flat road, if you see my explanation, I use here in green with the car for flat surface Fn is equal to mg. So I replace Fn by mg directly. No, I have everything here. Just I need to substitute the values. Fs is equal to mu s is given to me 0.60, mass is 1000, and g is 9.8. Can you please multiply them and give me the final answer for Fs?
Mr. 5880.
Okay, 5880 Newton. Umar, are you with me?
So it will follow the curve, right?
Yes, yes.
Umar, what about Fc frictional force? Is it greater or less than Fc?
It's greater.
When it is greater, what will happen?
If this is greater, it will not slide. It will continue.
It will continue. It will follow the curve. Okay, it will move. It means that one answer is there. It will follow the curve. Thank you so much. Okay, now let us move to the second part. If you see in the second part, what they are saying in part B, the pavement is icy. Now it is icy, it is not dry, and mu as you can see it is less now. It was
And the
0.6, now
friction
it changed.
decreases.
So friction will decrease. Let's see how much it decrease. Either still decrease to 4500 or it is more than that. So part B, I'm going to solve part B. Fs is equal to mu s mg. Mu s is 0.25. M is 1000. G is 9.8. Can you give me the answer, please?
Mr. 2000
24,050.
uh,
Yes, 2450. Am I right? Is it
yes,
the same?
yes.
Okay. If it is the same, what result you will depict? Friction is no less than centripetal force required.
It will skid.
So it will skid. So car will skid off directly. So now I think so you guys understood a little bit that when a car is going to take a turn, it requires a centripetal force. This centripetal force will be provided by the friction. If amount of frictional force is more than required centripetal force or equal to required centripetal force, car will take the turn. If it is less than that, car will skid directly and it will not take the turn. Okay, let us continue with this example. What he is asking for,
The coefficient of the static friction.
how we write coefficient of static friction?
It's the MS, right? MS,
Mu
right?
s, not ms, it's mu s. So
Sorry.
we have to find mu s. Okay, now second thing, if
25
the
Newton.
car is too round the level
Yeah.
mean flat. So for this one also Fn is equal to mg.
Okay.
Okay, this condition is also there. Okay, it want to take the curve of radius is
125
given.
meters at a speed of 95 kilometers per hour.
Okay, now first of all, before we start, we have we have r, and they want us to find mu. But the question has one hidden thing, that car will take the turn. If the car is going to take the turn, what was the condition?
If the
Oh,
friction is
What was the condition?
you lagged a bit, but
Yes, yes, please.
FS and FC, if it's greater.
Greater or equal for car to take turn. The minimum requirement is for car to take the turn, FC should be equal to Fs. This is the minimum requirement. If
Yes.
Fs is more than that, then still it will take a turn. But if it is not equal or less than equal, then it will not. So
Yes.
minimum requirement is Fc should be equal to Fs. So this is our condition for car to take the turn. Starting from this condition, that Fc is equal to Fs, Fc was equal to m v square over r,
Squared over R, yes.
and fs was mu s mg. I can write mg directly because fn is here
Equal mg, yes.
flat surface. It's a level road. Okay. Now we guys are very well aware the mass m is used for the same car. So whatever the mass we don't need, it is m and m are cancelled. Yes.
Okay. So V
So
squared is
yes, v square over r is mu s times g. We need to find mu s. So g,
72.2, the first one.
no, first move the equation. We need to find mu s. So g on the other side will divide. So what will be the expression? Mu s is equal to
I put it
v
mu s
square over
squared over R multiplied G.
g. Very good. Now just substitute the values. But before one, there is one very big issue. This velocity is in kilometer per hour.
Yes.
We
So we
need
need
to convert in meter per second. Do you remember how will you do?
it's 9,500 meters per hour, right?
So in meter per second,
Okay.
9,500 divided by 3,600.
I
So
know an hour
directly, directly you can say 95 divided by 3.6. It will give you answer in meter per second. And in my opinion, it is 26.3.
Should I check?
Yes, please check it out. I calculated it previously. 26.38.
It's 26.3, yes. 38.
38 bar.
It's
So this is meter per second. Now substitute the values. Mu s is equal to 26.388888 square over r is 125, g is 9.8. Can you give me the answer?
The answer is 0.568.
0.568. So I have to round it off because 95 has two significant figures. So you
So
will
it will
change it to 0.57.
570.
I will tell you one more interesting thing. When you will write the coefficient of friction, then you don't need any unit. So this is unitless quantity. So mu s is a constant, a number. So it does not have unit. What is the maximum speed? The first thing they are asking us to find is the speed. And you know that speed or speed maximum, we will use v or v maximum, which is unknown for us. Okay. Secondly, the car is having a mass of 1,200 kilogram. So I will mention here in given data that mass is 1,200 kilogram. And car is going to take a turn about radius of 90 meters. Third thing that is given to us, the radius, that is 90.0 meters. So 90.0 meter is the radius of the turn on a flat road. This is very important word. Whenever the flat road is written, I told you for a flat road it is for sure that fn it will be equal to fn will be equal to mg. For a flat road, fn is equal to mg. So if I am going to use the equation of static friction, so I will use this one. Fs is equal to mu s mg because Fn is equal to mg. Okay, now, and the last thing, they gave us the value of mu. Mu is the coefficient of friction, I told you last time. And they gave us the friction between the tires and road is mu s, that is 0.65. And there is one more thing, I already told you last week that it has no unit. So it does not have any unit. So if in future I ask you in the quiz what is the unit of coefficient of friction mu, so you will use no unit. Okay, this is the given data. Next thing I will discuss about in meanwhile the mass or not. So I will discuss this thing also. So we are going to find velocity, and also we have to check that this car is 1200 kilogram. If there is another car that is 1000 kilogram or 2000 kilogram or 10,000 kilogram, will it affect on the velocity of the car or not? So for that purpose, I'm going back on the condition of a car to take a turn. The condition of a car to take a turn is that this friction should be equal or greater than Fc. So minimum value of friction that we require is equal to Fc. So I'm going to use this condition, that according to our condition, this static friction Fs should be equal to Fc, and we are very well aware that Fs is equal to mu s times mg, and Fc is equal to mv square over r. Now what I need to find, I need to find v. So first of all, I will check what is cancelable. I can see this m, the mass, can be cancelled by the mass. When mass is cancelled, the remaining expression is mu s times g is equal to v square over r. As r is divided here on the other side, I will take it and it will be multiplied, so it will become mu s gr is equal to v square, and if I need to find v, I will take square root on both sides, so v will be radical mu s gr. Now this is your required expression number one that I am going to use for finding the velocity. So this relation tells us that velocity v is independent of the
Mass.
mass. So this is independent. So it will not be affected by mass, independent of mass. So whatever the mass is, velocity is not going to be affected. So velocity is equal
Velocity.
to root of mu s is
0.65.
0.65, g as usual 9.8,
Yes.
r is 90.0. So when these are the values which we are going to substitute, so how much is the v?
23.94.
Okay, 23.94, and unit of the velocity is
Unit of the velocity is meter per second.
meter per second. Okay, when unit of the velocity is meter per second, and how many significant figure we require? If you see, mass is given in 2 significant figure, radius is given in 3, mu is given in 2. So minimum number is
2.
2. So how will you convert
24.
it into 2 significant figure?
We will make it 24.
It will be 24 meter per second, and you can see the second part of the question was, will this velocity be independent of mass or not? That I already wrote here, that this velocity is independent of the mass. Either mass is more or mass is less, it will have the same value of velocity. Thank you so much, guys. I'm hopeful that you understand this topic and also this
Yes.
example